Thanks, Sophie. The first thing I need to tell you guys is that the computer's way over there and you guys are over here, so as long as you're okay with feeling alone, isolated, far away from me, you can stay there. I'll try and wander over here. The screen is here, so the computer is very far from the screen, actually. The second thing that's very important, I'm not a mathematician. I'm not very good at math at all. I know very little about any math beyond algebra. And the way I use R, I've discovered, is very different from how mathematicians frequently use R. And the R users group is some mathematicians and me and a political scientist, and that's it. So it's mostly mathematicians, and so I'm learning how mathematicians think about things a little bit differently. And for me, R is a data analysis platform. So if you want me to do something different and find out if R can do something different, you're going to have to be bold and assertive and say, excuse me, can it do this? And I will try and find out if I don't know. I might not know, but I will try and find out. So I know where the two of you in the front are from. You're from mathematics. And what department? Math?
I'm from MBA, but I had a background in mathematics.
Okay, so business and a math background. That's probably a very potent combination. And where are you from? Mathematics? Yeah, you're math. I know you're from math. And you are from biology. And Dr. Watkins is from mathematics, and Sophie is from mathematics.
From statistics.
Oh, statistics, right. In my mind, I separate statistics and math, but...
Yeah, that's in my mind, too.
But I think, I don't know, I could be wrong. Statistics isn't really my area of greatest expertise, but it feels to me like statistics is just a really wonderful area of applied math. But for me, I was never interested in math until I could apply it, until when it was playing games with numbers and looking at the patterns. Some people love that. I have a father-in-law who was a lifelong mathematician, and I think that's just what he enjoys. And he can work for a month on a very complicated theorem or something, and that's wonderful for him, and I don't have the attention for that. But give me a problem to solve with real data that came from people or came from institutions or something, and where mathematics can tell me something that I didn't know before about that problem, and I get very excited about that. So it's very good. This level, I think the little green thing is supposed to go up more.
I'm sorry to interrupt you. I think I want to notice that. I have engineering background.
Oh, you're from engineering.
But I'm using statistics in applied. Maybe I think that's a common difference. What else have you been in background?
Let me see if I can figure out how to...
That's math. Engineering. Biology. We don't have another biology.
Uh-oh, that's not good.
See, you have a good mix. You have two here, and then some math.
Okay.
So this is a mix.
Well, that's good.
Population already.
It's a little bit more mixed. But one of the nice things about R is that it wasn't developed with a specific population in mind as some previous software. So what are people hoping to get from learning something about R? Like, why do you want to learn anything about R? Maybe I should switch to my other screen. It looks prettier. There we go. So let's start with Mario. Why did you come? Just curiosity, or?
Yeah, I know that it's going to be used in statistics class that we'll be taking, so I just thought I would get ahead and start learning about it. It seems, I like statistics in general, so whatever I can learn is like a good idea.
Okay, that's great. So what about here in the back? Why are you guys interested in R? What do you hope to get from learning R? Is it because you're in classes that require it? Or are you just hoping to gain new skills? Or are you going to analyze some data?
I got interested in statistics like 2 or 3 years ago. Dr. Wang introduced me to that area. So it's
I have met you before, haven't I? I think I met you two together.
Yes. She was my graduate student. She graduated last year.
I think I remember meeting you. Okay. So anyway.
Okay. So I think I know R is a specific software, statistics software, and I want to know how to use it.
Okay.
Maybe I can use it just in case that I can't solve some problem in other statistical software.
Okay. Anybody else want to say why you're learning statistics?
And I think even one
pretty famous. No, why would you want to meet me? That's very strange.
Because of my topic, my thesis is related to the social.
Am I working on your thesis now? Am I working on your dissertation?
I should say yes.
You're the person.
Yes.
All right. Woo. All right. I met you. All right. That's excellent. One thing you should know is there are a lot of other statistical software packages out there, and most of them are designed with a lot more user friendliness in mind at the beginning. In my mind, this tends to limit some of the things you can do with them down the road, but they're all fairly powerful and flexible. Stata or SPSS or SAS, you can do a lot of things with those. You can do a huge number of things with those. In my mind, the languages that they use behind the pointing and clicking are not as easy to use and not as flexible. And the pointing and clicking itself limits you in ways that are kind of annoying. I've used SPSS for years, and it was a little bit of work to switch to R, but now it's really difficult to imagine going back to SPSS because I know how to do things so much faster and so many more flexible things I can do in R than I could do in SPSS. And one reason is because R isn't just a statistics program, it's a computer language. So this is what I'm hoping to do with this class. Have 2 classes. Today's part 1. We'll talk about some, well, this outline might not be totally accurate. Some general information about R. I'll try and make sure there's information about how to get help because that's very important. R doesn't have the same kind of user manual that some other kinds of software does. There's a lot of information out there on how to use R, but finding that information requires slightly different steps sometimes. And how to do some very basic things. And then in part 2, I might go back on some more data analysis type tasks, some more data analysis tasks, and try and showcase some areas where R has advantages over some other software, hopefully using things that people will learn in their own data analysis. So how many people here think you're going to do empirical research? I know Even already is, but anybody else? I mean, that's what I do. I collect data, I analyze it, write reports. You guys are going to be doing scientific empirical research. You probably are, Mario, is my guess. Just because you're from biology is the only reason I say that. Okay, well that's what R was mainly developed for, but it's very flexible beyond that. So if you want to install R on your own computer, most of the time it goes pretty smoothly, but like all software, every once in a while there are glitches, and sometimes it doesn't install the way you wanted it to. There are versions of R to install for Apple, for Windows, and for Linux. And it installs nicely on all of them. In my experience, the installation process is the easiest in Linux. Installing anything is usually easier in Linux if there's a package. And R is very well known and very well distributed in Linux operating systems, different Linux distributions. So if you're using Ubuntu or Red Hat or Debian or something like that, there are very good Linux packages available for those. There are CRAN mirror sites. CRAN is the Comprehensive R, what's the A? Analysis Network? Comprehensive R A network? Something. Anyway, CRAN means the R organization. It's free and open source software, and there is a small corporation at the core of it that helps develop it, but it's like a not-for-profit corporation or something like that, Revolution Analytics, and they use R to develop more fancy tools that they can sell to businesses, and part of that money funds R development. And there's a core group of developers who I think get a little bit of money for their time, but mostly they're volunteers as well, developing the code since the 1990s. So it's almost completely run by volunteers. So when you get to CRAN, the CRAN website, just look in the operating system that is yours. So there will be links for folders for Apple operating system, for Mac OS, and for Windows and for Linux and things. And you can find where to download R. But we're just going to use classroom computers today. I forgot I brought this. This could be very useful. This might start working. It takes a couple of minutes. We're going to use classroom computers today. So if you want, you can just go ahead and start R. There should be an icon on the desktop. There might be 2 icons. If so, I don't think it matters which one you use.
Or you can put start.
Maybe, but I think they put some icons on the desktop. I think when IT installed it, so you don't even have to use the start menu. You can just double-click the big blue R on your desktop. So that should be easy to find. We won't start using it for another couple of minutes. I have some other little intro stuff. I don't know if you're interested in this, but there was a statistical program named S, and I think it was S for statistics. Really original. The development apparently started, this is just me Googling online, in 1976, and this was associated with Bell Labs, and a lot of really amazing things over the years have come out of Bell Labs, and S is one of those things. S was later developed into S+, but it's still basically the same thing. In the mid-1990s, there were some people who ported S+. They created a free version of it, and that free version they named R. I don't know the story behind that, but it is right next to S. So anyway, they didn't realize at the time probably that they were creating lots of problems for people trying to use Google, because it can be difficult to Google just a single letter. But there are ways around that. And there was a little study a while ago where some people, a couple of years ago, tried to estimate the number of R users that exist, and the estimate was anywhere between 200,000 and 10 million. So we don't really know. It's hard to tell because people don't have to pay for it. People might download it as many times as they want. Every time you get a new download, it might be a new person or it might be somebody who already has it. In some countries where internet connectivity is a little more difficult, it's known that some of this software is distributed like on flash drives and CDs and stuff like that instead of by downloading all the time. So one download could mean 100 people. So it's really hard to estimate. But just looking at the conversation traffic on Google, you can track the number of times people are searching for R topics, and that's skyrocketed. So there are almost certainly millions of users at this point. So R, at its core, it's just a language. It's like C++ or Python or Ruby on Rails or something like that. But it was developed principally to be useful for data analysis, for statistics and data analysis. And so it has some functions that are aimed in that direction, that make some of those things easier. Now, there are people out there I've learned who use C and C++ and C# and Python, especially for statistics, and people who use Java and JavaScript for statistics. So you can do an awful lot of statistics with other languages as well. I think the difference with R is, A, it was developed with that in mind. So you're not taking a generalized language and trying to make it do this, which those languages can all do. But B, there's so many people using R now, and they all have kind of a similar core of ideas. It's all about data analysis in some way. There's a lot of different things people are doing. It's not all analyzing empirical data, but there's a critical momentum there of people using this. Now, when you download R, you're going to get the base package, and you're going to get some other packages. Now, all the packages, it's just a computer language, right? And in computer languages, you can write a function. You can use the language to write a function to do things. Well, if you get a bunch of functions written, in R, you can put them together into one file that's called a package. So a package is just a collection of functions. And that's how it's been since the beginning. Well, the base package has the core functions, the essential low-level functions, like adding and subtracting and multiplying and dividing, and or, and handling data, and the basic things we don't have to think about very much. There are lots and lots of other packages, though, and many of those are included when you just download R. If you just download R and you aren't doing anything really fancy with your data, you could go years without ever having to download any other packages sometimes. I download them all the time, but you don't really need to most of the time because there's a lot of stuff included when you download it. But if those aren't working for you, I think the estimate right now is that there are about 5,000 packages that you can download freely through CRAN. So if you Google and say R package and then put in the name of some package or just a word describing what you want to do, some of the Google results will probably be what you want to do. So if you say R package ordinary least squares or R package data, like longitudinal analysis, you'll probably get lots of hits, and researchers out there are writing their own packages. Some of these packages are written by the core R team who does this, but a lot of them are just people who are researchers who write their own functions, and then they say, hey, this is a nice function, I should share it with other people. So what can R do? At first I had the phrase, what can't R do? R can do a lot of things. basic statistics. It can do your descriptive statistics, some things like chi-square and non-parametric stats, analysis of variance. That's good to know. I thought it was something really complicated. No problem. Thank you very much. And this is more data from that experiment. So I'm just showing you that even without doing anything super fancy, you can show the results of very complex analyses sometimes. This is just 4 groups. That's a bit of a crazy graph. It was from a poster we developed with my students. We showing these different responses with 4 different groups of people, 4 different lines. So there are 4 different groups of people and different responses of how helpful they thought certain things would be to rape survivors in this particular case, sexual abuse survivors. So that was something we did for a graph a little while ago. And those are 95% confidence intervals, so we can see the comparisons right up there. Although I think this is a little bit busy, maybe a little assaulting your eyes. But here's some pictures of some other people's graphs, not mine. I got almost all of these from just a website that's a gallery of R graphs. So when people make an R graph that they're especially proud of, sometimes they submit it to this gallery, and this gallery has hundreds of graphs now, and I really like looking at it sometimes. So here's another version of a correlation matrix showing you different versions of scatter plots. I don't actually know the difference between the scatter plots in the lower and the upper triangle, but this is going to be a kernel density estimate. There's very nice. This is something that can be done with R very easily. Well, not very easily, but very effectively and relatively easily. You can use data files that have coordinates showing outlines of countries, outlines of cities and towns, and then you can feed data from R that has GPS information in it, and then you can make nice maps like this. I think these were election results from 2012 with red and blue. R has some 3D mapping abilities. My understanding is that they're a little fussy to learn how to use. I haven't had a reason to use them yet. You can do very silly things in R. This is a professor who said one of his students asked, can you just use R to draw smiley faces and happy faces? And so he made this graph using R code. And there are a number of very silly graphs that you can find out there. This is a scatter plot where the angularity and the color of the ellipses shows you the strength of the associations. I believe red is positive associations, blue is negative associations. So this is kind of nice, using one of the built-in R data sets for car data. So this is a kind of a corellogram. Here's a more commonly seen corellogram. You've got scatter plots down here, and then you've got just the ellipses and the low S smooth lines up here. This is for baseball data. That's one of the built-in data sets for R. Here's some more map data. This is Hurricane Sandy that just hit the East Coast. Here's box plots. These kinds of things are very easy to do with a number of different groups. And I don't even know what this is, but I thought it was so pretty. It's a heat map, obviously, but I don't know what it's representing. It was on the Pretty R Graphs website, and I thought it was so great. And I think it's very nice how they worked out their scale, and they got 4 panels in there. It's very nicely done. So basic R resources, there's the comprehensive R network. So that website can point you to a lot of other help. Google. There's a mailing list called R Help mailing list, and the archives are online. You don't have to join R Help. I did that for a little while, and my inbox was flooded. I put it all into a subfolder, and I was getting hundreds of messages a day. It's very busy sometimes. And there are some very knowledgeable experts on R Help. They're not always nice, but they're very expert. So it's nicer to look online and see them answering other people's questions than to ask yourself sometimes. You can also look in Google. There are a lot of websites that are created for R users to teach R users how to use R and how to do new things. A lot of websites for beginners. Lots more for advanced users of R. You can use Google if you want. When you're using Google, you can put brackets around the capital letter R, and that used to force Google to look for an R. So, and that was kind of nice, because it can be hard to search for just one letter. Google gets confused. But this used to be a way to force it. But there's also a Google clone. It uses Google technology, but it searches just for R-related top content, and it's called rseek.org. So that's a nice place to look as well if you're looking for information about anything having to do with R. But I spend a lot of time on Google. Everybody I know who uses R That's where you go if you have a question. You check the help in R itself, so all the functions have a help page that comes with them. And when you write a function and submit it to R, you have to write a help page to go with it. So that usually works. But if that doesn't work, you try this, and you see how other people are using it. And then the R users group has a Blackboard course shell where we're trying to assemble some resources as well. That's under development, but there are some resources there, some links to some books and some links to some websites. So if you're interested in that, you can talk to Dr. Watkins, who manages it, or to me later, and we can see if we can figure out how to get you access so you can access the tools that are on the Blackboard course shell. There are a lot of books out there. My students like this one. It's very, very thin. So little. I think it's only about 20 pages, 30 pages. It's paperback. It has a fun cover. I'll put this online so that you guys can all see it. And this is a link that'll take you to the Amazon website where you can look at that book. It's about $20 or $30 though. But it is useful. And it's very simple. It explains only a very few very basic things. It has nothing advanced in it at all. And my students in my undergraduate class really enjoy it. They say it's very clear and very simple and a good way to get started. There's also this book that I recently read reviews of. I haven't seen the book. It's called Statistical Analysis with R. I think it's a big book. And I've heard that experts in R get bored reading it, but people who are brand new at R really enjoy it. So that sounds like a good book to me. I would probably enjoy it, because I'm not an expert. Then there's this. This is an online, you can Google this phrase if you want in quotation marks. It's on the CRAN website. It's on the R network website. This was written, I don't know by who. It's online, free, but it is a little hard to plow through. It's a little bit dry. It's a little bit boring. Sometimes it's a little too technical, I think, for beginners. It tries to be for beginners, but I don't think it's always the easiest thing to use. There's tons of stuff out there. There's a website called QuickR, so quick-R. If you Google that, you're nodding. I love that website. Every time I Google something, it's like the first thing that comes up, how to do this in R. And it has good explanations. It sometimes has examples and pictures. But there are dozens of websites like that. And there are hundreds or thousands of scientists' blogs who just occasionally post something about R. And there are a lot of statisticians who post things about R all the time. So there's just a lot of content on the web. And my recommendation is if you don't understand it, search again or find something simpler. So let's do something. Let's use R as a calculator. So use R and use some of these things. Just start typing things in. Type, like 1 plus 2. Now, the operators are very familiar if you've used any computer programming languages before. Plus and minus are easy. But the asterisk, Shift 8, is for multiplication. The slash is for division. So if you do 1/2, the result should be 0.5. Exponent is caret, which is Shift 6, I think. So if you do 5 caret 2, you should get 25, so 5 squared. And then there's a couple of functions that are really nice. The square root, now I put x in there, but if you do square root parentheses 25, you'll get 5. If you do sum, well, maybe we'll worry about sum later. Maybe I shouldn't have put that one in there quite yet. You have to know about multiple values. But just try using it as a calculator. Just try typing a couple of things. And notice a few things. First of all, you don't have to wait. SPSS became very frustrating to me because it's still based on a code system, and SAS is the same way, and Minitab is the same way, and there are a lot of them that are the same way. I think Stata is more like R, but they're not interactive, and R is interactive. SPSS, Stata, these old software programs, you have to write your code, and then it's a program, and then you submit the whole program to the system, and then you wait to see what happens. And with R, you can do it that way. You can write a bunch of stuff and submit it all at once, but you can just write one thing at a time. You can just say 1 plus 2, and it'll say 3. So it's very nice. You can do things quickly and interactively. You can try things out. Dr. Watkins has taught me the beauty of trying to break it, of trying to make errors happen on purpose, because the errors are very informative. So is anybody finding anything weird in trying to do this? Anybody run into things that they want to do that they cannot do? I'll give it another minute if people want to do a little bit more of this. But I think people have satisfied themselves.
early on, R was a standard part of every Unix and Linux system because it was just kind of a nice handy little calculator, among other things.
It's funny to think of people using this funky system just to like 2 + 5, balance my checkbook. But it works for that. It works very nicely. It's sophisticated. It follows good rules of operation, order of operation. So it should follow the order of operation that people are familiar with. I discovered recently that Blackboard does not. That frustrated me for a long time. Dr. Watkins helped me figure out how to force it to do what it was supposed to do. So it's surprising that not all computer languages follow the orders of operation that we are taught in school, but R does, I think. I don't think I've ever encountered a situation where it didn't. So this isn't like you have an assignment. This is the assignment operator. Now, Dr. Watkins likes equals. I like less than dash. It's 2 characters, the less than and then minus, together with no space between them, because it's an arrow pointing left, because it's like this. This is how you create objects. An object is just a string of characters that's a name that refers to some information. So you can think 5 is now packaged. You can think of the object like a box that has something in it now. So if you do this, or if you do x equals 5, it will give exactly the same. I'm going to keep doing the left thing, but every time you see this, if you want to use equals, you can just use equals. It's the same thing. They will do exactly the same thing as far as this course is concerned. Dr. Watkins likes equals, but I can't force myself to switch. So I'm just going to go with what I know. But you can do equals if you want. By the way, spaces, no spaces, that has to be no space there if you're going to use it as an assignment. But you can put spaces here between x and the equals and the 5 if you want, or you can do no spaces. It's okay. It doesn't matter. R is smart. It will figure it out. Sometimes you'll run into a situation where it can't figure out the spacing, but almost always it understands.
I think the arrow assignment can also assign to the right.
Yes. Yeah, you can do dash greater than, but I've never done that. So it seems weird.
Equal only assigned to the right.
That's good to know. Yeah, but the arrow assignment, you'd need to type a different one. You'd have to type hyphen greater than to do that. I've never done that. I just use this. But there are people who use this instead. I like this because it looks like a little arrow. It looks like the 5 is going into the x. It's traveling into the x. And for me, that was very important. I hadn't programmed before, and I think that's very important to me because the basic programming tools, I'm not good at them. So learning how to just write syntax was difficult for me sometimes, and I think that's why I liked the arrow so much, because it looks like what it's doing. It's the 5 is going into the x and sitting there. So if you want to see what's in your object, just type its name. So now x is the name of an object that contains the number 5. So if you just type x, you should see a new line, and it'll say line 1, 5, or item 1, 5. So you can also do character data, but character data has to be enclosed in quotation marks. By the way, not these quotation marks. PowerPoint did this. You need straight quotation marks. R will always do straight quotation marks. But if you can use single or double, it doesn't matter. What you should not use is the back tick, which is up in the upper left-hand corner that looks like a single quote, but it's not a single quote. So you can use the single quotation or the double quotation. It doesn't matter. And it's handy that you have both, because sometimes you have a double quotation, and within that you need to use single quotations to set something off. So it's nice that both exist. So this creates an object named phrase. Now, after you do this, if you type phrase, then you should see hello world. And that's character data. And in R, there's a strong distinction between number data and character data. So if you typed quotation mark 5, a 5 in quotation marks, you would not be able to do any mathematical operations on that 5, because R would think it was just like a letter. Yeah, it would think it's text. It was characters. So, but that's usually pretty easy to tell, because without the quotation marks, you can't get any character data. R assumes everything's numeric most of the time. And if you want it to be text, then you have to force it to understand that it's text by putting quotation marks around it. And so sometimes if you forget that, R will say, I don't know what this object is. And you say, oh, that's because it's not an object. I just need to put the quotation marks around it. So now if you want to see what we call your workspace, try typing in ls and then open close parentheses, all with no spaces. ls open close parentheses. That means list. It means list all my objects. So you should see X and phrase. Yeah. No, not X, just ls and then open close parentheses. So shift 9, shift 0. There you go, and hit enter. Okay, so you didn't do X5 and then phrase. So you have no objects. So that's what that's telling you. There are no objects in your workspace. And you're seeing that you have 3 objects there. So yeah, if you use ls with open close parentheses, that just tells you all the objects you've made, which is nice because sometimes you can generate hundreds of objects at once and not be aware of how many objects you've created. So why don't you try to do this? Try to create a couple of objects, one object with a numerical value, one object with a text value. This is very simple. Give them short descriptive names, and there are a few little rules for names. The names can be big, long words. You can have a name. I had a student who created, she was showing me her work, and I said, okay, so where's your object where you put this data? And her object was named something like, Jillian's data is in this object, please do not touch it, please, or something, all with no spaces. So you can make really long names, that's okay, if you want to type them all out again someday. So I recommend short just because you don't want to type forever. And it's case sensitive, so a capital letter is very different from a lowercase letter. If you create an object that is like a capital X, and then you try and find it by typing in a lowercase x, R will say, I don't know what you're talking about. There are no lowercase x's here. So capitalization, you start to think about that pretty quickly. So the names can be any text stream, but it cannot start with a number. So you can I could call my object Darren1 with no spaces, but I could not call it 1, the letter 1, or the number 1 Darren. R would get confused at that. So you can't use a number to start the name, and there can't be any spaces in the name of the object. Sometimes people just use a single letter like X or Y or Z or something like that. X is, a lot of people just do their objects X if they have nothing else, but usually you need a lot of objects, so you use up the X and the Y pretty fast. And there are only 2 special characters you can use in the names, and I use these a lot. Underscore and period. So if my name is like Darren Data, I might do Darren.data, and you can do that as a name. So just create a couple of objects, give them some names, just make sure you can do that. I think you probably all can. If anybody has any problems doing this, just let me know. I'm going to get a drink of water. Now remember the names of those objects, because we're going to mess with them a little bit. Now the text one can be any length you want. Actually, so can the number one. You can give it a 45-digit number if you want. That's okay. The text one, in between the 2 quotation marks, you can put anything you want, except another set of quotation marks, because then it'll think it's over. So you could write the entire novel Moby Dick in between the quotation marks. And in fact, what we in our users group were discovering when we were doing text scraping from the web, we were scraping batches of text, some of the functions that exist for that will take huge batches of text and make one string out of them, which is useful sometimes. And there's stuff in R that will help you break them up into little strings and find out the number of letters and stuff like that if you want to. Is anybody having any trouble, any questions with this part? Okay, ready to move on? Individual values are sometimes stored in objects, but it's much more common to store multiple values in an object. I mean, like statistics. When you put the X at the top of your page, you don't usually just write 1, and that's your problem. You write 1, 2, 7, 3, 12, 9. I mean, you put all the values of X. You put the values of your data. And that's a vector. And we use this operator, C. And then whatever goes in between the parentheses, separated by commas, all becomes one thing. Not all smushed together, but R will treat it like a family, I guess. Say, you're all members of the same family. You all come from the same tribe. So that's the concatenate function. I sometimes don't want to say the whole concatenate thing, so I say C, and then people that don't know what I'm talking about, so I have to say concatenate. So it clumps together a lot of values into one space. And so if you use that to create an object consisting of, say, several numbers, and you separate the individual numbers with commas like this, then you can have X mean a lot of things at once instead of just one thing. So X doesn't have to just mean 5. You don't have to create X is 5 and Y is 3 and Z is 10. You can say X is 5, 3, 10, et cetera, et cetera, et cetera. So you can have all the values in a variable, for instance, in one object. So try that. Put a whole bunch of numbers, any numbers, in X or some object. So it's going to be the name of your object, and then either equals or this arrow, and then C, open parentheses, number, comma, number, comma, number, comma, number, comma, and then close parentheses, enter. And this is one fairly useful way to get data into R. And my students, most of them prefer to get their data into R this way. They would probably rather type in 20 or 30 numbers like this than use some other methods that I think are simpler. But it's not that bad. It takes a little typing. Now I notice that some people have started to open Notepad, and they type their stuff into Notepad, and then they copy it and paste that into R. That's a very smart strategy because, well, if you ever want to see what you typed into R, just hit the up arrow, and you will see at the cursor all the commands you've typed in. You'll cycle through them. That's your history. So if you ever want to see the things you typed a few minutes ago in R, just hit the up arrow key, and you'll see your history of things that you've done. However, in my mind, it's usually easier to work from a text document where I type in my commands, and then I copy them, and then I paste them into R. There's easier ways than that, too, but if you're interested, that's one thing you can do right now. Anybody find anything weird about creating an object? Did anybody have any problems? Couldn't create it? Then, of course, you can see what's in the object by just typing X. I almost compulsively do that. After I create an object, I type the name of the object so I can see what's in the object. But there's a trick you can use if you want to type the name in and see what's in the object all at once. Let's see, did I start R? Oh, I didn't. Maybe I should start R also. What? What? I think this is telling me that R is on all your computers and it's not on this one. Okay then, I'll just rely on you guys to do this. Let me just show you what you can do. If you do this, if you enclose the whole thing in parentheses, then every time you do something in R, there's a good chance that if you do the whole thing in parentheses around the beginning and the end, then it will not only create the object, but also show you what's in the object. So it can do two steps at once. It's kind of nice sometimes, because I find myself doing this, and then I type X. And X is easy, but if I named it like Darren's data, and then I have to type Darren's data again, and I'm doing that like 100 times in an hour, my fingers get tired. So sometimes I just do the parentheses. That's just a trick so that you can see what you just did without having to do an extra command. Are there any questions so far? Anybody run into problems? This is amazing to me. This is good. Try a character vector. Character vectors, if you wanted to have Jane, Fred, Alice, and Jeff all in one object called friends, there are two ways you could do it. You could put quotation, Jane, Fred, Alex, Jeff, close quotation, but then you'd have one text string with a bunch of words in it. Sometimes what you really want is a bunch of different text strings that you can manipulate independently. So you can say, I want to get rid of the first one or the last one. And that's easier if you make them individual text strings. Now, I know this is a no-no in English syntax, but we put the quotation marks outside, or the commas outside the quotation marks. So it's still values separated by commas, but now it's text values in quotation marks separated from each other by commas. By the way, these spaces, optional. You don't need spaces between the commas. So just so we can do something a little bit later, create something like this. It doesn't have to be these, but just create a vector of at least 2 or 3 or more character strings. I used friends, like my friends equals these 4 people. This is very optimistic. I'm not sure I have 4 friends, but we'll work on that. So create a vector. So try to replace your previous 2 objects with new objects while you're doing this vector. The way you do that is just give them the same name as an object that already exists. And this is both a wonderfully easy thing. So if you already created X, then create another X, and the first X disappears forever. You've deleted it. You've replaced it. So this is very efficient, but it can also be extremely frustrating if you forget that you created this object, because there will be no warning message. There will be no, are you sure you want to replace this object? You just have to not do it. So it's very nice to replace the objects when you need to, but every once in a while this can lead to some frustration. So once we get to where you have 1 numeric and 1 character vector, then we'll do some things with those. Manipulate them a little bit. Does anybody need to take a break? It's been almost an hour since we came here. Break? Keep going? What's your preference? I was secretly hoping that Sophie would bring us snacks, but she didn't say she would, so it was a vain hope. All right, so now that you've got these things, let's do some things. You can do math operations on a vector, and that's more interesting in my mind than doing math operations on an original thing. So you should have a vector of something. So let's say your vector of numbers is x that has multiple numbers. Try doing this. Type x times 5. You don't need spaces, or you can put the spaces. It doesn't matter. R is smart. So this assumes you have an object called x, and it has multiple numbers. Multiple number values in it. There you go. Awesome. Now, one thing to notice, now if you just type x again, x didn't change. X times 5 just shows you what x times 5 is, but it doesn't change the object. If you wanted to change the object, does anybody know how you would do it? Sorry. Ideas? How would, if you wanted to change x, each value in x to be 5 times the original value, how would you do that? Yeah. So you would, now this probably seems so basic to you guys, but this was hard for me to learn. So you would say x, the same name. So make the new x equal to the old x times 5, so change x. And R is fine with that. You don't have to create a new object or anything. It can change the old objects around. It can be very dynamic and recursive that way. And you can do anything. You can do x minus 1, x. You can do big, long, funky, complex operations. But it can be more interesting if you create a new vector called y that has the same number of values in it as x does. So if you put, let's see, I have 1, 2, 3, 4, 5, 6, 7. I have 8 values here. And I think I originally up here put 8 values in x. So create a vector called y that has the same number of numeric values as x has. So I don't know how many your x has. You can just type x and count the number of objects that are there, or the number of values that are there. And then create y that just has some other numbers. It doesn't matter what they are, just some different numbers. Now make sure you have the same number of items in X as you have in Y for what I'm going to suggest later. Then you can just type X minus Y and see what the result is. We could do X plus Y, X times Y, X divided by Y, X times Y to the third power minus 8, whatever.
Half an hour over there, half an hour over here.
You
So
sound busy.
I'm taking 2 courses together.
I always tell my students not to do that, but you're obviously much more skilled.
Yes, I'm serious, Popo.
So as long as these are the same length, then your result will be a new vector of the same length as both X and Y. Now, there are a lot of choices R could have made. It could have summed up X and then subtracted the sum of all the numbers in Y. It could have done matrix operations. Actually, this might be matrix operations. I can't be sure. But R does what we call vectorized code. So if you take Y times 5, it'll give you a vector that's the same length, and it'll have 8 times 5 and 7 times 5 and 12 times 5, etc. So if you do an operation on a vector, then R assumes what you want to do is repeat that operation once for each item in the vector. And that's not what every language does. Not every computer language has that understanding. And if you want to do matrix operations, then you need to use different operators. And if you're interested in those, I can help you figure that out and Google them. Or Dr. Watkins probably already knows them at this point. But it doesn't do matrix operations by default. Well, it does them by default, but not with these operators. These operators assume that you just want to do this to every element of this vector here. And that's a very particular choice that R has made. And it makes some of the data processing very easy and very nifty sometimes. But if you're trying to do matrix operations, you need to learn new operators to tell R, I'm trying to do matrix multiplication here. I don't just want to multiply everything on my matrix times 5. I don't just want to multiply each item in this matrix times each item in this matrix and have another matrix that's the same dimensionality, that's the same rank. So there are certainly ways to do that in R, but it's not with these operators. These operators just take each individual item of one object and match it up with the item of the other object and do what you asked it to do. If it can't match them up, then it gives you an error. So there's a function called paste that puts text together. So you could try this on your character vector. With mine, I put the names of 4 friends. And so you can do paste, and then the name of your character vector, so open parentheses, the name of your character vector, that's the first thing you put in paste, and then a comma. And then the next thing is what you want pasted onto the end of each one of those things. So I put inator, and it doesn't really matter. You can put anything you want. And then a comma, and the last thing is what should separate those two things. And so I put separation equals, and notice I have to do quotation marks everywhere there's a non-numerical value, always. I get thrown off by that a lot. So separator equals dash. So try that and see what happens. It made a humorous result for me when I had my friends vector with friends' names in it. That you don't have to put inator. You can put anything you want. You can put
And the hyphen sign.
Sorry?
So it made me a feeling that you're old-fashioned. Because I believe S plus use that.
Yeah, R is S plus.
Yes, but R can take equal sign. R take equal sign.
Oh, this?
Yes.
Yeah, we talked about that. Dr. Watkins likes the equal sign. I like the assignment, but there are different styles. Dr. Watkins' version, the S plus version, or the R version, is more efficient because it's only 1 keystroke, whereas mine, I have to do 2 keys. I have to do less than dash.
Yes.
So I've probably wasted thousands and thousands of keystrokes. It makes my hand hurt to think about it.
Well,
But it's an old habit I have.
This when we see, because in our statistics department, some people still stick with S plus, some people use R. So it's just to us, say, okay, if you do this, we know you're from.
But it sounds like this is more versatile because it works for S plus and R.
Yeah.
So I'm right.
Yes, you're right. You are right. You are right.
I'm joking. I admit it's just a habit with me, and I've seen people use equals a lot as well. It seems like it goes either way, but I like this one. I'm probably going to do it until I'm forced to change, if I ever am. So, did you guys have good results with this? I don't know what quotation marks are there, but those are weird quotation marks. Do you see these quotation marks? They're straight. But those quotation marks, they're angled. I don't know how you're getting angled quotation marks. Have you set your keyboard to a different language, perhaps? Oh, you pasted from... Oh, don't use this. Use Notepad. This is wonderful. We even just showed us something that I was going to tell you about, but I thought, that's too complicated. Microsoft Word or OpenOffice or LibreOffice word processors will give you different characters, and you don't notice they're different, but to the computer they are different. So Even was unable to do this because she pasted from Microsoft Word, and Microsoft Word, when you type this, it replaces these with different quotation marks. And R does not like those new quotation marks. R wants it very, very simple. It just wants these straight ones, and it's hard to force Microsoft Word to do that. So I recommend if you have a document open that you're pasting from, don't use Microsoft Word, use Notepad. Just use Notepad or the script editor.
Yes,
Either one.
Is much better.
I just barely, I'm so embarrassed. I don't know about script editor. I use RStudio all the time, and I just missed the script editor. It's apparently really cool, and I don't know how to use it. So feel free to use script editor. I'll try and figure it out before next time. I hope it's not too complicated. You guys know how to do it. So yeah, the error was that you had angled quotation marks, and that's just what Microsoft Word does. It tries to make everything pretty, but pretty doesn't work well with R. R is not pretty. R is ugly and useful or something.
Straightforward, not ugly, we're just straightforward.
Yes. I find a raw and severe beauty in it. I'm going to watch over your shoulder. Yeah, you can make empty quotation marks too, and that means the separator should be nothing. And that means the words will just be packed up against each other. There you go. Awesome. So you've seen that when you do something to a vector, the thing you do goes through every piece of the vector, every item in the vector, and does it one at a time. And this is an important thing in R. So what if you put spaces in your expression? Like what if you do x space, 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 plus 5? Does that change anything? Did anybody get any errors from doing that? No, it shouldn't change anything, right? I don't think it makes a difference most of the time. Inside quotation marks, the spaces are a character by themselves. But outside quotation marks, most of the time, R ignores spaces. The spaces are nice to get in the habit of because it makes your code easier to read, but they're not important. I get in a hurry and I just don't put any spaces in my code. When I'm thinking carefully, I put spaces in so you can see. So sometimes you'll see some spaces between parentheses up here, but that's just to show you what's going on. You probably don't need the spaces. What happens if you use single quotes instead of double quotes? Any guesses? I think we already talked about this. It shouldn't make any difference at all. You can use like the apostrophe key, the single quote, instead of double quotes. And in fact, some people really prefer that. I don't know why, but some people really don't like using double quotes. Maybe it should be just because the single quote, you don't have to hit shift, right? You can just, in the English keyboard. So maybe it's just because it's easier. So I don't know, but I know some people really don't like double quotes. They like single quotes. But it doesn't matter most of the time in R. Well, there's one place that I know of in R where it's very important to use single versus double quotes. So there's a function called recode. So you can say recode x, not capital R. And then you have to tell it what, see how it did those angled quotation marks? Grr. You have to tell it what to do in the recodes. And the way the recodes go is something like a equals 5, like 4 equals 5, 5 equals 9, 3 equals 2. So this is a way to recode all the values in a variable. It's a nice little function. However, if you have any character values, text values in your variable, you need quotation marks around the text values, but this whole thing has to be in quotation marks, and the text has to be in quotation marks. But if I put a quotation mark here, then it thinks I'm done, and then I get an error. So you have to nest single and double quotes in this function, and I've gotten used to it. So if it's like a GPA thing, and I want to change the GPA numbers to letters. So that's an area in which, by the way, this function will not work for you because it's in a package that you've not downloaded yet. It's a package called car. It's a wonderful function. I found out a lot of people download that entire package. It has hundreds of functions, and all they want is this one thing because it's so useful. But this is one area in which this makes a difference. You have to use double on the outside and single quotes for the characters on the inside. But most of the time, it doesn't matter. You can just find little problems here and there. So the what? I haven't. Single on the outside and double on the inside? I think it'll work. My guess is it'll work either way. I think R just cares that there be different. But I was just thinking about that. I wonder if Will's going to ask that. I was thinking, I should have tried that so I'd know the answer. But I haven't tried it. Where did I put my... Oh, I put it right there. Okay, so we're worked up to the point where we're using functions. Are we going at a good pace? Is this too slow? You want me to speed up a little? Can you go faster? Do you want me to... Okay, I can go a little faster. I did lots of coloring, and Guillermo made fun of me for this. But this is the way functions work. Functions just do things to other things in R. So you put values or objects or something in a function, and you make the function do stuff to it, just like a mathematical function, f of x, so, or any computer language. So the way this works is each function has a name, and then after you type the name, in parentheses, you put the arguments. Most of the time, at least one of those arguments is an object that has data in it, or you just type in some data inside the function. It doesn't matter either way. But not always. Sometimes they don't take data. But usually it's function and then some sort of a data. And each function is defined to have multiple arguments, and you can write your own. It's not that hard after you've been doing this for a little while, after you learn the basics. But it's just a way to do a bunch of funky things at once, to do something complex instead of more simple. And so it always works that you write the function name, parentheses, the argument, comma, other arguments. Sometimes there are 10 arguments or 100 arguments. Usually it's just 2 or 3 for a function. And then you hit enter, and something happens. So mean is a function. I write functions with open closed parentheses after them, or sometimes I put x in the middle. So for instance, your x and your y values, you should be able to do mean of x. Put an x in there, like mean parentheses, x, close parentheses. I follow the convention that there's no space between the name and the parentheses, but it actually doesn't matter. Some people put a space there. R is smart. It says, that was the name of a function. I bet there's going to be something. Wait for it, wait. Oh, here it is. So R doesn't care. You can do it either way you want. So mean is a function. You could do it to your x and your y vectors if you want. SD is standard deviation, so you can get your standard deviation very quickly. And this is where I really think R starts to be useful, because it's a calculator that can do really fast stuff with the speed of a hand calculator, but it can do very complex things. So you can get your mean and your standard deviation, you can get variance, you can get standard error, you can get all kinds of stuff. You can do table. Table will give you a frequency table of anything. So you can do table and then show your character vector in there. Are you guys understanding how to do this? You do table, parentheses, and then friends, close parentheses. Or table, open parentheses, x, close parentheses. It'll give you a frequency table of anything. And you can put as many objects as you want in tables, separated by commas, And it will give you multi-dimensional tables. It will give you two-way tables and three-way tables and four-way tables. It gets too hard to understand at some point. I usually do two-way tables only. Summary is a very nice one. That would tell you a lot of nifty information about any object you put between those parentheses. So if you type summary and then anything, it will give you good information. If it's a numeric vector, try it. It'll show you the 5-number summary plus the mean. So summary is a really quick way to see what's going on with a variable in your data. Length is very nice. It tells you how many items are in your object, how many different entries. So if you did x equals c and then you had 10 numbers there, then length of x will be 10. It'll show you how many things are in there. And I use that more than I ever thought I would. It's very important sometimes to count in your code the number of things that are there. You can just tell you how many subjects in your experiment if you want to do a quick check for that. So it can be very nice. It can help you see, did I type in the right number of things? I was supposed to type in 20. Are there 20 there? Instead of counting them, you just do that. And then, of course, we can assign the output or the results of a function to an object. So, for instance, we could create an object called deviations of x. So I could name it dev.x. No spaces here, because in a name there can't be any spaces. I could say dev.x equals x minus the mean of x. And so I could create an object that's just the deviations from the mean in object x. Like I was going to start working toward making a standard deviation or a variance or something like that. Everybody with me so far? Questions so far? Yes?
The length, if you put in a vector, it gives you the length of the vector.
Yes.
If I put in a matrix, but mainly we want to use a function dim to get the dimension of the matrix. But then I thought if I put in length, it's going to be nothing. And it gives me an 8.
It gives you the total number of elements in the matrix, right?
That's amazing.
Yeah, you entered a 2x4 matrix and you did length of the matrix and it said 8 because there are 8 elements. Yeah, I've done that before. And it was frustrating the first time I tried to use these things that are supposed to be vectors on matrices, because sometimes I wouldn't remember that it was a matrix and I'd think something was happening and it wasn't. But later I found out it can be very useful to read a matrix as a bunch of individual values every once in a while. Sometimes that's what you want, because maybe you just want it to run through everything. And so it's kind of nice. Almost all of these functions will do different things for different kinds of data. Not all of them. Many functions in R will do different things if you give them different kinds of data. They might do one thing if you give them a vector, another thing if they give you a value, another thing if they give you a matrix. And usually the thing they do is a very useful, natural thing. The people who wrote the code tried to make this work nicely. Not always the case. Sometimes the thing they do is the thing that is the most useful if you were to use this function in a program, in a script. And so then it gets frustrating. So you could create z-scores, for instance, by taking that object and feeding it into another object. So if you created the deviations from x, then you can say z is the deviations of x divided by the standard deviation of x. And you could create z-scores very easily that way. Of course, there's an easier way to do that. There's a function called scale. So if you just do scale of x, that gives you z-scores in one step. Most of the time, there are very easy ways to do the things you might want to do, but not always.
I gather that's a common, right? Pound, C, scores.
Yeah, I'm sorry. I should explain this. I've gotten used to doing this. In R reads by lines, and if it gets to a pound sign, it ignores what comes after it, so that's a comment. So that's a comment you make to yourself or to someone else in your code. So if you've written a few lines in Notepad and you want to remember what it's for, either on its own line or after you're done on the same line, you can do pound. R will ignore everything until the end of the line, and then on the new line, it will pay attention again. So a pound anywhere on the line means from there on out, it ignores it. So you can just write notes to yourself. So that's what I use that for. It's called a comment. Yeah, thanks for noticing that. I hadn't pointed that out.
Something is annoying is, if you use different language, the way they use a comment sounds.
Yeah. SPSS you have to do either slash asterisk and then at the end asterisk slash, or you have to do star and then a period at the end. It's really, SPSS as a language was written in the 1960s, and every once in a while it shows. SPSS doesn't do anything unless you type execute period at the end of the line. Oh. Yeah, somebody came to consult with me 2 days ago, and she brought, from education, and she brought some of her data. It was really an interesting study, but she was using SPSS, and I was just thinking, I hate this. Oh, we need to do, oh, we can't do that. This is SPSS. Okay, we have to click, 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 click. Okay, we can just do this one command. No, we can't. It's SPSS. So I've really gotten used to R. But yeah, the commenting is similar to, I think, Python. Does Python use comments like this? Is that right? Okay. I just started to learn a teeny bit of Python a little while ago, and I know nothing about it, but I'm trying to remember basics. So if you want to learn R, maybe we can make a deal. You teach me Python, I'll teach you R. So go ahead and try this. Use some kind of a function on one or more of your vectors and assign the result to a new object. And then type the name of the object so you can see what's there. There's lots of functions. If you put the name of your vector here, it will calculate the mean. As you can imagine, if you put the name of a character vector here, you'll get an error. But go ahead and try it if you want. Standard deviation, put a numeric vector name there. Summary, either one, anything, that'll work. Log, obviously this is going to require numeric because it'll give you the natural log. Table, anything. Table works with anything. It just gives you a frequency table. If you're feeling funky, you can look up a new function. Now, the way you look up a new function is you type question mark and then the name of the function. So if you're thinking to yourself, oh, these are easy for me. These are boring. I want to do something new. Well, then type question mark SEQ, not with this part. Just type question mark SEQ or question mark RBind. You don't have to do these. I just put those up there in case you want to look up a new function and see if you can figure out how to do a new one. Or you can do the old ones.
You could add sum to the suggested functions.
Oh, yeah, sum. Good heavens. Sum. That's a great idea. SUM. This is what happens when you write your presentation a little too quickly. Oh, yeah, these are weird. They're magnetic and they look like cell phones.
You already did length.
Sum of eraser.
You already did length.
Yeah, we had length up there. I didn't write it up there. But you can use length. Length works on just about anything. Did anybody try any of the new functions? Did you look them up and see what they do? Now, I think the only two that will, up there on the right, that will do anything if you don't know what you're doing are sort and casefold. Sort and casefold, you should just be able to put a vector in there. It should be fine. Casefold, you need a text vector, a character vector. And sort, I think it'll work with anything. Sort will just put things in order. Did anybody try casefold on their text vector and see what it does? It's one of my favorites. Just a teeny little gem. You gonna try it? Can you see what it did?
Made everything lowercase.
Yeah. Yeah, it turns everything into lowercase. I love it so much. When you import from SPSS, there's a way to import your data straight from an SPSS file. And I do that a lot. And in SPSS, frequently, people have named their variables with capital letters, which is fine in SPSS because you don't have to type them very much because you're pointing and clicking. But when you get to R and you have to type your variable names a lot, I don't want to have to constantly hit caps lock or hold down the shift key. So I sometimes use casefold as the first thing I do to change everything to lowercase. So that's why I remember that one, because it makes it easy to type. Are there any questions? Anybody want to ask a question, share anything that they've found as far as we've gone here? Would anybody like me to wait a minute before I move on? What time is it? 3:30? We're getting close. I may have judged the length of this fairly well. That's kind of shocking to me. Are there any ideas people have and you're wondering if there's something you could do? Although I'm not sure why you would wonder. You just do it and see what happens. You'll get an error message generally. But if you do it the right way, beautiful things will happen. Any questions? All right, let's move on. Let's just do quick graphs. Try this. Histogram is just hist. So feed that, put in between the parentheses there, the name of one of your numeric vectors. I really wish R was on this machine. I can't believe it's not there. I want to go do it too. So it makes a nice, quick little histogram. Now, if you want to make your histogram pretty, you can do like this. You can say hist, the name of your vector, and then comma. There's a lot of things you can add to any graphics. One of them is color. So you can say COL for color equals, and then in quotation marks, you can either put the name of an HTML code, a hex code, pound whatever, or you can put the names all in lowercase letters. There's like 200 different names that R understands. And so most of the time, if you guess at a color name, it probably knows. It knows all the basic ones, like red, blue, green, yellow, purple, green. And it knows things like magenta and fire brick and sky blue. Like literally, there's a couple hundred names. But you can also give it an HTML code, like, pound FF00A6 or whatever. So anytime you're doing graphics in R, you can just feed it colors. There's usually somewhere in the graphics function something where you can give it some pretty colors. So histograms I love, because I don't know any other software program that's so easy to get a histogram. And the developers of R, I think, put a lot of thought into making sure that when you start up R and you're analyzing your data, you can do some very simple things very fast, and they're the things people want to do when they're just looking at their data the first time. You want to do summary and find out the minimum and the maximum and the medians and the quartiles, and you want to do histogram and see what the distribution looks like. And you want to do plot and just plot one thing against each other. Now you can do bar plot, but this requires some explanation. Bar plot will not work if you just use your numbers. Well, it'll do something if you use your numbers. But it will work best if you do a table. So you might want to wait on bar plot. I have an example for that later. But a scatter plot is easy. It's just plot. And you just put in two vectors of the same length separated by commas. So plot x comma y. That will give you a scatter plot of your x and your y variables. And you don't have very many points in x and y, so it'll be a pretty thin scatter plot, but that's okay. You know how to do it now. You did bar plot, right? Now, with your x and y, if you do bar plot, you will see something, and what you will see is a bar chart where the height of each bar is one of the numbers in your vector. I think that's what will happen. Because bar chart, most of the time, for real data that has hundreds of values, you need to do a frequency table first, and then do a bar chart of the frequency table. But if you just give it a few numbers, it thinks it's already seeing a frequency table. So if you ever just think, I want to fake my data, I want to make it look so that category 1 had 5 and category 2 had 10, just type in 5, 10, 12 into the bar plot, and there you go. So bar plot is really nice for faking your data, and if you get caught, then you might get fired from your job. Scatter plot is nice. It's just plot x comma y. And we'll do this more in a little bit here. There's also more than one way to plot a mathematical function. Now, Dr. Watkins was suggesting the way that I usually use it, but I also looked up the way that I've seen online, and they're both kind of neat. So first, you could build a vector of values, for instance. So you could do this. The sequence operator takes from and to and by. And this will create 0.01, 0 to 10, so what, like 100, 1,000 values? If I can do my basic math. So this will create a vector with 1,000 values in it, going from 0 to 10 by 0.01s. So if you create that, and then you create another vector where you did something to those values, like you took the sign of them, the sign of the value plus 2, and then you have two vectors that you can just plot against each other. Oh, you made an upside down bar plot. That's awesome.
There were negative values.
Oh, that's sweet. So it started from, that's very smart of it. That's nice. And then when you plot them against each other, now I put CEX equals 0.1. You don't need that. All you really need is plot vals, vals.p. CEX means the size of things. In graphics, this is a size. So make it 1/10 of the normal size. Because I was trying to get to where you could see the individual dots, but there's so many values that the dots just connect into one line. I was trying to show you how you could connect the dots with a line, but you don't need to because there's so many values here that I made that they all get connected. If you put CEX equals 0.1, then the points get very, very small. CEX means character expansion factor. If it's positive, then it makes them bigger. If it's less than 1, it makes them smaller. So you don't need this. You can just do this and then close parentheses if you want. And you should see a nice sine wave function plot happen before your eyes. You can make lines connecting them if you want. There's a function called lines, and you just feed it x values and y values. And I told it the color red, and I told it the line width should be thicker than normal. It should be 2 instead of 1. So that'll draw over the top of that all those dots and make it a thick red line, I think.
That is, LBD is very useful because when, by default, the line is usually thin, and when you want to publish the features,
Yeah.
so you have to make it thicker.
There are tricks you can use. Like you can edit your R. When you've installed R, there's an R profile file, and you can put code in that R profile so that you could say all my lines should always be 2 width unless I specify otherwise. So you can change all the defaults if you want to. And then there are ways to save your graphs as PDF and to anti-alias all the lines so that it makes it look nicer for publication. There's lots of tricks, but I look them up every once in a while. But yeah, they're really jagged and pixelated by default.
But another way I learned when we did this is interesting. You use latex.
You what?
You use latex.
Oh, yeah,
bring
latex?
the graph in. You can change the latex there, and the width of the line also changes.
Yeah, Guillermo's very good at that kind of thing. Guillermo has messed with that. Guillermo in the R users group, one of your faculty. So I see a lot of people got the nice little line there. There's an easier way to do this. This. You can just do this. Curve sine x plus 2. The curve function, you just feed it a function. You feed it an expression. Now you could just end after this x plus 2, but it will automatically only plot the expression over the range of 0 to 1, which isn't very interesting. So I added this line here, x limits. So the limits of the x-axis should be, and we have to use this C operator, 0, I gave it 0 and 10. You can give it anything you want. So you can put this all on one line, by the way. I broke it up into multiple lines. R will be fine with that. If you're not done with a function and you hit enter, then you will see that your prompt changes from a little arrow to a plus until you're finished and you close all your last parentheses. And then I made the color and the line width. But this will just plot a curve. You don't need all the last 3 lines, but they make it more pretty and more useful.
The x in this expression is not one of our objects, is that right?
No, it's not an object. It's just an abstract x that it uses to compute the expression.
We have put there something like 5 times x plus 3x plus 4.
Yeah, you can put anything you want. Anything that evaluates into a mathematical expression will work. Or at least that's what the help file says. So as long as it evaluates nicely. And you might have to change the axis so that you can actually see what the function is doing. But. So this is something I don't use very much at all because I'm not very much into, I rarely need to make an abstract object, an abstract function. I just, instead of doing a sine curve, I might just check for, a cubic trend in my data or something like that. And so I would use different tools. But this stuff is apparently used frequently by teachers of mathematics so that students can figure out functions and geometric relationships. Okay, moving on here. Let's do one thing, and this will be the last few things we do before we go. We're getting right into the end. Let's get some data in the way that I usually analyze it, and a lot of people analyze it, in a big matrix of data. So do you guys know CSV format? If you use Excel or OpenOffice or something like that, a spreadsheet, you can save it as comma-separated values. Now, this is not all R can read. R can read anything. It can read uniform values where you've used spaces to put all the values in columns. It can use read tab-separated values. It can import directly from SPSS. It can import directly from Excel, and I need to figure out how to do that because that would be very nice for my students. Type your data into Excel and then import it into R. But I use CSV, which is like a really dumbed-down version of Excel with no fancy anything. Excel reads it nicely, but R also reads it very simply. And I give my students my data like this. So I put my data in Excel or SPSS, and then I just save it as CSV, comma-separated values. And then there's a function called read CSV, and it puts the data into a data frame object into R. So read CSV, and then you tell it the name of a file that's on your hard drive or a file that is on the internet. So I put some of my data on the internet for my students. So this long thing says create an object named pun, because it's a punishment attitudes data set. And you don't have to do this, but I've started to try and do a capital P for my data frames. A data frame is going to be a big matrix with columns for variables and rows for participants, rows for subjects. So that's just something I do. So create a new object named pun and create it by read.csv, this URL. So this URL is http://Darren L, my middle name is L, Rogers.com/static/data/pun.csv, and that's lowercase. So type all that junk in there, and then it should pull from my website that CSV file and create an object in your R workspace. And this can be very nice. So straight from R, you can actually pull in tons of information from the internet if you use the right functions. And I found this is really nice to distribute my data to my students so that they have something to work on in class. And then you can do ls, open close parentheses, to make sure that pun showed up, that you did create the object. Sorry, it's kind of a long URL there. If you get an error, then, oh, awesome. So you got it. So you just typed in pun? Mm-hmm. Yeah, and if you type in the name of pun after you've got it, it'll just dump the whole thing on your screen. It'll be kind of ugly because it wraps around, but I'll show you some ways to look at it that are a little easier in a minute. Oh, it looks like you have it. So try ls, open close parentheses. Just type that in there. Try to list your objects. So just ls, open close parentheses. I think you've already done it. I don't think you need to do it again. There it is. So it worked. So if you list your objects by typing ls, open close parentheses, you should now see one named pun. You got it? Okay, I think everybody has it now. Is there somebody who still doesn't have that data frame? It looks like it worked. There you go. All right, so if you want to view what's in there, there are a lot of different ways to view your data. The first thing I always do is type names, and that will show you the names of the columns, in other words, the names of the variables. So if you do names of pun, you should see, I don't know, it's like 20 different names or something, 30. Yep, 25. On average, I was right. If you want to see the first few values, people sometimes do this. Just do head pun. That'll show you the first few lines. It'll wrap around, though, because there's too many variables to show all on one line. You can also type tail of pun. That'll show you the last ones if you're interested. People sometimes do that just so you can see what the data looks like. If you want to see information about the variables, there are two really useful functions. You saw that summary gives you information about an individual vector. But if you do summary of an entire data frame, it'll show you information about all the variables. It's very nice. And then if you do str, that stands for structure, that will tell you what type of variable each variable is. So it'll probably say int, this is an integer variable, or num, this is a numeric variable, or chr, this is a character variable. So these are things I frequently do when I import a data set just to make sure I got everything that I needed. Is everything going okay with everybody on this side of the room? You do sort of outnumber Mario, so. So you can do any of these things to see. You can also try edit of pun. And that should bring up a big matrix spreadsheet that you can scroll through and look at all the values. Despite the fact that it says edit, I have not had any luck actually editing the data on Windows systems. You'll feel like you're editing the data, but it probably won't save any of the changes. So it's more like just look at it. If you're using RStudio, there's something called View that does something very similar and has a couple of advantages. But you're not using RStudio right now, so I don't think this function is available to you. Well, it might be. RStudio is installed on your computer. You might try View with a capital V. It might work. I'll peek over your shoulder and see if it works. Nope. Apparently it's not there. Apparently you have to be using RStudio. Yours works?
I was going to ask how to get out of here after...
Just close that window.
Oh, this is an additional window.
Yeah, it'll open up a separate window for your editor, and you can just close that editor window, and it shouldn't change anything. So these are ways that you can see your data. We've only got about 10 minutes left, so let's see if we can play with the data a little bit before we go, without rushing too much. Does anybody need me to slow down, wait for a minute while you do something? I don't see anybody asking me to, so all right. So working with data frames, there's one important rule you'll need to learn before all the other ones. You need to learn how to use the $ sign, because there are all these objects in your workspace, so you can't just type in the name of a variable. You have to tell it what data frame it's part of. So you type in the name of the data frame and a $ sign, and then the name of the variable. No quotation marks or anything. And R will know to find that variable. So, for instance, in your pun data set, there's a variable called p.age. And if you type in names of pun, you'll see that's one of them. That's the participants' ages. If you want to see all the values of that, just type that in, and then they'll all scroll down in a big block of numbers. Not a very useful way to see things, but sometimes it's handy just so you can see what the values are all doing. If you want the summary statistics, oh, sorry, there's something in there that doesn't need to be in there. That's something I failed to edit accurately. Let me get rid of this. That's inaccurate. Now it's accurate. So if you want to see the summary statistics of participant age, then summary of pun $p.age. If you forget to type the pun $, R will remind you. It will say there is no object called p.age. So bad things will happen, and then you'll say, drat. Okay, try it again. This time I would type pun $. So this means in the punishment data set, the p.age variable. If you want to see a histogram of religious fundamentalism scores, hist, pun, $relig.fund. If you forget what these names are, you can always type names of pun and just remember what the names are. This should be a pretty nice looking histogram, I think. Yeah, oh, that's a good one. Positively skewed. Not too bad. So basically, any function, instead of just feeding it a number or feeding it x or friends or whatever, you feed it the whole name, pun, the name of the data frame, $, the name of the variable. Now, there are ways to not have to type the pun $, so much, and we might talk about those next time. But for right now, just this is the easiest way to make sure you're getting the right thing. If you want to see a nice scatter plot, you need to type in x variable and a y variable. So we asked everybody, we gave everybody the right-wing authoritarianism scale, and we also asked their age, so you can see what right-wing authoritarianism scores look like by age. So x is age and y is right-wing authoritarianism. And of course, you'll get kind of an ugly plot, but you could make it pretty if you added colors and things if you felt like it. Does anybody notice anything in that right-wing authoritarianism plot? Does it look like there's two separate groups of data? Yeah, so Mario's noticing this. There's a cluster of people just clustered onto the left-hand side of that scatter plot below age 20, more or less, and between, well, below 25-ish. And then there's a larger scatter plot, like shotgun blast, over to the right. That's because in this study, which was my dissertation, I gave surveys to two groups of people, to therapists and to undergraduate students. So the therapists have a nice normal distribution of age across the age range, but the undergraduates are all like 18 to 20. So you can see that from the scatter plot. It's kind of nice. And these are things I do frequently, just quick checks to see what my data looks like. And these are things that take many, many mouse clicks in SPSS. So I love R for doing this. It's really awesome. Now, one problem is having to remember the names of these functions. And there's lots of ways we can get around that, lots of little help functions, and I'll go through a few when we get to the end here. We've only got a few minutes left. So try this function, box plot, and look at this little tilde. Some functions in R use this tilde, which you can translate as meaning by. So this will show you box plots of people's ratings of offender accountability, of sex offender accountability. They filled out a questionnaire. They saw a little story about a sex offender, and then they filled out a questionnaire saying how responsible or accountable is this person for his actions. And then there's the subject group, APA, which is American Psychological Association Therapist, ATSA, which is Sex Offender Treatment Professionals, and then UGS, which is undergraduate students. So you should see 3 box plots, and each box plot is the distribution of these accountability ratings, and 1 box plot per subject group. And this tilde is why that works. So some functions allow what we call the formula expression here. Now, if you put a comma here, then you'll see 2 box plots, but you'll see the box plot of this for everybody and the box plot of this for everybody. If you put the tilde, then it says this by this. So it'll do this number of times. And that's very useful for all sorts of analysis functions. Okay, yeah, these are looking exactly what we'd expect. And you can see that those accountability ratings are higher among undergraduate students and lower among therapists. It's kind of handy.
So the sub.group column only has 3 items in it, 3 choices.
Exactly.
The APA, the ATSA, and the UG.
And if you want to verify that, you can just type in table of punishment $subject.group, and you will just see that the frequency table only has 3 entries in it. And so I use table an awful lot. You can also just type in the name of this, and all the values will scroll down, and you'll probably see pretty easily there's only 3 things happening. Yeah, so it's easy to verify once you get in the habit of using the right tools to verify, but it took me a while to get used to this after SPSS, where you're always looking at the data matrix. And now I'm a little more comfortable with this stuff, honestly, but it took a while to get used to not having the data matrix in front of me all the time. And you have to think in different ways to do that. So here's a nice bar plot. So if you want, we divided up the offenders. They weren't real offenders. They were just stories of sex offenders that people received in their surveys, and their ages went from 7 to 27 years old. And then later I went back and said, I should divide that up and clump up together the children, the teenagers, and the adults. And so if you just type the middle part, table of this, then it'll show you a frequency table, how many children, how many surveys had child offenders, how many had teenage offenders, and how many had adults. But if you do a bar plot of the table, then you will see a bar chart showing how many surveys had child offenders, how many had teen offenders, and how many had adult offenders in them. So bar plot is an odd little function because you can't just feed it regular data. Well, you can, but it always assumes that every value is the height of a bar. So if you want a good bar plot of raw data coming out of your data set, then you have to feed it a table. You have to give it a table, a one-way frequency table, to make a good bar chart. Actually, you can give it a two-way frequency table too, which is fun.
How do we change, because the bar graph right now, the reading is count, frequency, how do we change it to relative frequency?
Relative frequency? Well, one thing you can do is you can do a function on the table to turn those into proportions, but there might be an option in bar plot as well. I'm not sure. So if we're in histogram, for instance, there's an argument you can flip back and forth between whether you want a probability estimate on the y-axis or frequencies. I don't know if there's one like this. Yeah, that's the right. Well, if you do it divided by 1,000, that assumes there's 1,000 people in the study. Well, this is something you might try. Here, let me just... well, there's an easier way to do that. Let me just... Did you figure it out?
That's why I asked you, if you know the sample size, or maybe somehow we find the sample size.
Yes. So this is what I would do.
There you go. You got it. Relative.
Yes. So if you do just the table, that'll give you a frequency table, right? And if you do the table divided by the number of rows in the punishment data set, the number of rows is the sample size. Then that should give you a table of relative frequencies. There's another way you can do this as well. There's a function you can wrap this in called prop table. Don't do that to me. Prop table of the table. So you can do that. And that'll give you a proportion table. And if you put that all in here, or if you create an object out of the proportion table, here, let's do that. So you can do this. Let's see. So if you did this, those two steps should do it, I think. So Sophie's question was, how do you make relative frequency instead of cumulative frequency? Now, the better answer to that is maybe that you get on Google and you Google for somebody who has written a better version of the bar plot function that has a little something you can type in and say yes for relative frequency. And there's probably somebody out there who has done that. But if you want to do it yourself, this is a way to do it, I think. I'm interested to see if this works. Did anybody try this and did it work?
It worked.
This code?
Yeah, divided by the n row,
Okay.
that will work.
Yeah, n row will work because n row is the number of rows in the data set, so that's your sample size. But this should work too because prop table of the table will give you relative frequencies in your frequency table. So I think that should work, maybe. Is it not working? Oh, no, I was wrong. Try just the prop table part. Can I do this? Okay. Prop table, oh no, sorry, we do need that. Okay, so that works. So now try bar plot parentheses. and then go to the very end, hit like the end key, and do another close parentheses there because you added one at the beginning, so you have to add one at the end. Yes. See? 0, 0.1, 0.2, 0.3. So that does work. That's good.
Well, you can always adjust the sort of proportions, right? So this is about 50%, about 30%, and just over 20%.
Yeah, there are ways you can make like grid lines so that you can see exactly what the percentages are. There's a way you can write the percentage in the middle of the bar so you can see that. By default, it looks like the R thing is not extending your axis as high as it could. You can put a Y limits function in there to force the axis to go up higher. There are a million different ways you can adjust that so that it looks a little better. Did I put down my clicker somewhere? I probably put it down by the computer. Indeed, I did. Okay. Now we're about done. I want to skip really quickly ahead. Well, that's not going to work, is it? Because I'm not displaying anything. Well, I'm going to skip past this, and we'll just pick this up where we left off last time. So there's lots of different ways to make nice little plots. I'm just going to skip. We were going to do some quick regression. It's very easy. Analysis of variance, very one-line thing. So come back next week. If you have any data that you want to analyze, bring it with you. If you're interested in analyzing any data. If not, I will have plenty. I have lots of data, so we can practice on my data. But if you have some data and you say, I'm working on a project and I want to analyze this data, bring it with you and we'll work on it. You can always email me and ask questions. I'll have my email address up here at the end. If you have any questions, just email me between now and then. I will try to answer them. And then we'll just put up, well, I think I've put up most of this stuff here. I'll just leave that up. And I'll just write my email address on the board. I'm drogers1. Like there's what?
There will be a D. Rogers too.
No, I feel so dumb about this. They asked me what I wanted, and they said, well, usually it's like people just pick, my first day, people just usually pick their first initial and then their last name and then a number. I was like, could I pick one? And they're like, okay. And then later I found out I didn't have to pick the number. I could have just been D. Rogers. It was 7 years ago. Too many people have my email address now. I can't change. But that's one of my greatest regrets. I could have just been D. Rogers. I could have maybe just been Rogers. That would have been cool. But there may have been another Rogers at some point. I don't know. So anyway, I am all finished. We'll pick up where we left off next time and do some more data analysis. But I hope if this is not doing what you guys want, if you think, I really wanted to do this other thing, let me know. And if I don't know how to do it, I'll figure out how to do it if I can by next week, and we'll do it. Bring data, ask questions. If you don't bring data or ask questions, don't worry. I'll have data. I'll have stuff to present, some exercises, ways to practice, show you fun things R can do. We'll do some graphs and some analyses.
I would think, for students to learn, just based on when I do the SPSS times, bring their own data is times. It's
Yeah.
time consuming. So maybe use your data. We just listen to your story.
I have lots of data.
Yeah, I know you have.
Yeah, but well, if you have data you're interested in analyzing, one of the things you can do is you could email it to me with a description of what the data is and what you're interested in, and then I would have a little time to look at it and prepare something that takes very little time to explain. Where I don't have to try all the little things I try that don't work, because I do that. Try this, oh, that didn't work. Try this, oh, that didn't work. Okay, that one worked.
Well, I heard that, especially when I was working on one chapter of my dissertation, I'm using MATLAB and R at the same time. I keep confusing. Well, in R, I'm touching the MATLAB. But some part
They do a lot of the similar stuff, right?
Yes.
Yeah.
But MATLAB is, because MATLAB is really for math. There's some functions that we want to use. And at a certain point, MATLAB is faster. I don't know why, but maybe because of the variance.
R gets criticized sometimes because certain parts of its code run slowly.
Yes, I think that makes sense. MATLAB and to test that. So some part you're gonna, time consuming for computation, pass it out into MATLAB. Well, MATLAB is not that bad. Usually we pass it into C or C++.
I've noticed some people that are using R to pull information from PHP on their websites. So they'll have R running on their server, and their website is running, and then R is constantly giving them updated views of like their user traffic and stuff like that. So that seems kind of neat to me, kind of fun to do.
So, and then we let R run in the background. So we just leave it and then we'll go home. So next day, and the results there. And
That would be
then
nice.
The result is not what we wanted.
Oh, I remember, yeah. I was in quant psych, so everybody around me was statisticians, except me. I was from clinical, and I shared offices with them. And there were always 2 or 3 computers in the TA office for the graduate students. 2 or 3 computers that just had a sign on them that says, "Do not touch until May 14th."
Yes.
Because they're running some simulation that's going to take a month. Oh, man. Yeah, and they'd be so frustrated. They'd come in after it's done, and then they're like, "Who turned this off? Who turned off this computer? Ah! I wasted 2 weeks of my life." All right.
If it would be helpful, we could put people as students in the shell, and you could make copies available.
I should show people what's there. I think that can be a good resource. It's not as fully developed as we hope to have it someday, but it's got some neat stuff in it. Okay, let's shut down integrity here.